And I think we had done this, right? Can anyone explain this slide in your own words? If I give you this picture, how can you explain what's happening? Can anyone? Please don't be quiet. You can see spring and you can see ball. You can see a compressed spring and a ball. Now tell me what is actually the activity which has been executed over here. Can anyone? Can you hear me, beta? Boys, can you hear me? Hello?
Yes, ma'am.
Yes,
Hello?
ma'am.
Yes, can you hear me? Fine. So, what is shown over here? What is this picture trying to show? Can you tell me? I will join you, don't worry, but you begin first. What has been shown over here? What can you see? What are these? What are these? What is this? Say something.
Spring, ma'am.
Yes, what it is? Spring. Fine. Now this spring is attached, right? Can you see this attachment over here? It is attached.
Yes.
What I am doing? I am applying a force on this direction. I am applying the force in this direction. That means I am compressing the spring. Agree?
Yes, ma'am.
Yes. So the spring is being compressed. So the spring has got some energy. You agree? Hello. The spring has
Yes.
got some energy. Okay. Fine.
Yes, ma'am.
So what is this energy? It is not moving. I'm holding this compressed spring. It's not moving. So that energy is stored in the form of potential energy. Got it? Because it is, we are holding it. I have not released it. When we release this potential energy is converted to kinetic energy because of the movement. Now this is not moving. So the energy is stored in the compressed spring in the form of potential energy. Okay? Fine. Now you release it. You release the spring. You take away your hand. Can you see this? This is a ball over here, and your hand is over here compressing the spring. Now you take this hand away from the spring. What happens? The spring is released. Can you see this? The spring is released with a force because you remember that in the compressed spring there was a potential energy. So when you release the spring, this potential energy is released and it makes the spring move onto this direction. You can see the arrow, and the ball also moves along with the spring. So ball comes from here to here. Did you understand the work done? So spring works on the ball and makes it move from here to here. Did you understand?
Yes.
If it did not have energy, do you think it would have worked on the ball? No. It had the energy, so it worked on the ball to make it move from 1 to 2. This is what I wanted you to explain. So, what is spring doing? Spring is doing work on the ball. And from where it can do the work? Because of the force. Yes? And what is force? Energy. What was the energy? Potential energy. I hope you have understood now. Yes, beta? Hello. Yes?
Yes. Yes, ma'am.
Fine. So, any problem regarding this slide?
No.
Now we are going to talk about a catapult, what you call as gulel. In Hindi, in our language, we call it gulel, but in English, it is called as catapult. What it is called as catapult. Okay, so you are holding this catapult and you are placing a stone, and then you release it, and this moves like this. And with catapult, you can hit anyone. Okay, people usually play pranks using the catapult. But earlier time, the catapult was used to kill birds, kill small animals, you know, for eating purpose. So where this potential energy stored? Potential energy stored in this stressed catapult. There is the potential energy stored. And when you release it, you leave it, you take away your hand. So what happens? The work is done in the form of the force applied onto the stone. So the stone is released with a very high speed. In such a high speed that it can kill a bird, it can kill a small animal. Do you understand? So, where was the potential energy? The potential energy was in the stressed string. You understand?
Yes, ma'am.
See, we are talking about the work, we are talking about the energy, we are talking about the force, everything together. So, you should understand how the energy is stored and what happens when it is released, how the work is done. Now, what was the work over here, Vita? The work was firing the stone at a very high speed. That was the work. From where it did the work? Because it had the stored energy in the stressed string of the catapult. You understand? Yes? Work cannot be done if there is no force, isn't it? If there is no energy. Energy has to be in a very, what you call that, is stored form. Then and then you can use it in the form of work. Got it? We'll talk about elastic potential energy. Please begin. Yes, please begin, Beta. Hello. Yes, Sazan, Saheem, anyone?
What, ma'am?
Start reading yourself. I think you can see the
Yeah,
slide
ma'am.
onto your
Elastic
screen,
potential
and I've stopped.
energy.
I've stopped explanation, so you should begin.
Yeah. The bow and the arrow is one of the tools humans made to use elastic energy to do work. The farther you pull on the bow, the greater elastic potential energy you store. Also, pulling on the string of a bow changes its shape, which increases its elastic potential energy. When the arrow is released, elastic potential energy converts to kinetic energy and the arrow flies.
We're going to read a type of this is potential energy itself, but we are making it more specific as elastic potential energy. Why? We'll see now. Now, this is bow. Yes, this is bow, isn't it? And this is arrow. What do you say? Hello, hello. Can you hear me?
Yes, ma'am.
Yes.
Yes.
This is
Yes, ma'am.
bow, and this is arrow, right? So humans used to use this sort of tools to do work, to kill animals, that is, to defend ourselves or themselves. What were they using? They were using the elastic energy. Now, elastic energy is where? It's over here. The string is elastic. Remember, you can pull it as much as you want, isn't it? You have to pull the string. Then only it can do the work because the energy is stored in the string. You know that? And when you release it, the arrow goes with a very high speed, and that is work. Okay? Now, more you pull the bow. Now, if the bow is pulled this much, energy will be a bit less. You make it to the maximum, energy will be the maximum. Are you understanding? So, more you stretch the string, the more you pull the string, the energy will be the maximum. Have you understood this much? Hello?
Yes,
Did you
ma'am.
understand?
Yes,
Did you
yes.
understand this much?
Yes,
More you
ma'am.
pull the string, the energy will be maximum. The less you stretch the string, energy will be less. Now, when you are pulling the string, the shape has changed. Can you see this? The shape has changed. Earlier it was only like this. See, earlier it was like this. But when you pull it, the shape changed. That means it is increasing the potential energy. And when you release the arrow, what is happening? When you release the arrow, see this is stationary now. This is not moving. But when you release it, it starts moving. So what is converted? Potential energy is converted to
Kinetic energy.
kinetic energy. Now, did you understand? And you can see the arrow flying. So the movement, I have to already told you, the movement is equal to kinetic energy. Anything which moves has kinetic energy. I hope the things are very clear to you. Boys, and that kinetic energy is having such an energy that the work comes out as the arrow flying. That is the work. Who made
Yes,
it
ma'am.
do the work? Yeah, who made it do the work? The stress string. The stress string made it do the work. And what was the work? The arrow flying. You got it?
Yeah, ma'am.
We already know that energy gets converted from one form to other. We know that, right? Energy is neither created nor
Yes,
destroyed. We know that,
yeah.
isn't it? So what it got? It got transformed. So in the stress string, we had potential energy. And in the arrow, we have the kinetic energy. So from the stress string, the energy, that is potential energy, got converted or transformed to the arrow as kinetic energy, which made it fly. Is it clear?
Yes, ma'am.
Yes.
Yes,
Thank you.
ma'am.
Thank you. Do you want numerical now? Okay, read better.
Uh, an Olympic archer applies a force of 100 Newton in pulling back her bow by 0.5 meter. How much energy is stored in the bow?
Okay.
Elastic potential energy is equal to F into D. Elastic potential energy is equal to 100 into 0.5. Elastic potential energy is equal to 50 joules. Thus, 50 joules of work was done by the archer on the bow, which will be transferred to the arrow when it is released.
This is what we have learned. Any problem? Any problem?
No, ma'am.
That's it. You can find out how much is the potential energy uh, which is applied onto the string by pulling the string, and when released this potential energy got converted into kinetic energy. Yes, and we can find the how much elastic potential energy does the bow has for the arrow to move. So this is how you can find out because and she pulls it this much. Okay. So when she pulled her back by how much meter? 0.5 meter. So they are asking how much energy, this much. When she's pulling the string, how much, because which energy are we talking about? We are talking about potential energy. So where is the potential energy? In this. Not over here. This is stationary, not over here. Because until she, this stationary, it's not moving. So there's no energy as such. So when you move it, so the potential energy is gained, and then you have the arrow over here. Right? We have the arrow over here. So this energy gets converted to kinetic energy, and which one will have the kinetic energy? The arrow, and it starts flying. Okay. Now we'll see how the energy gets transformed from one form to other. Please continue.
6. Transformation of energy. The conversion of energy from one form into another form is called transformation of energy. When energy is converted from one form into another, the total energy always remains the same.
So what you should understand?
Remains the same. The
Yes, that is the main
total
point.
energy always remains the
Yes.
same.
Any form of energy. If
Yes,
like
ma'am.
electrical energy got converted into light energy and heat energy, then look at the bulb. You switch it on, you get the light glowing. Yes or no? So the electrical energy got converted into light energy and the heat energy. Now that heat energy is not accountable. But what we say, the electric energy got converted, got transformed into heat energy. So from one form, it is changing to other form without any wastage. Hypothetically, we take it without any wastage, but there is a waste in the form of heat energy. Do you agree with me?
Yes, ma'am.
Yes, sir. So in totality, if we talk it about hypothetical, then yes, there is no wastage of energy, but there is a conversion from one form to other. Got it? Got it, beta? So it remains the same. The energy is not wasted, so it remains the same. The way it began, when it ends, the energy remains the same. That means it is not wasted. This is the conventional definition. Now, what is this law of conservation of energy states? Please.
Laws of conversion of energy.
Conservation. Please, it is
Conservation, sorry.
conservation.
Uh, the law of conservation of energy states the energy can only be converted from one form into another. It can neither be created nor destroyed. The total energy before and after the transformation remains the same.
So you
Example.
agree? All of
Yes,
you
ma'am.
agree? Okay. Yes.
Example, let an object be allowed to fall freely from a height at the start. The potential energy is more. As it falls down, the potential energy changes into kinetic energy. The
Just a
potential
minute.
energy.
Just a minute.
Okay,
Just a
ma'am.
minute. Now, this is the body. Now, it is falling freely from a height. You agree? Here, you find this potential energy. Is the maximum. Agree? mgh is the maximum. But when it is falling down, this potential energy is converted to kinetic energy. You agree? Hello? Because it is
Yes, ma'am.
moving. The ball is moving. So potential
Yes,
energy is
yes.
converted into kinetic energy. You agree or not?
Yes, ma'am.
So what is decreasing? Potential energy is decreasing and kinetic energy is increasing. Agree?
Yes, ma'am.
Okay, fine. Thank you. Now begin.
The potential energy decreases. The kinetic energy increases. When the object is about to reach the ground, the kinetic energy is largest and the potential energy is the least. But
Just a
the
moment.
okay.
Just a moment. Now the ball has reached the ground. So which is maximum? The whole potential energy is converted to kinetic energy. Agree?
Yes, ma'am.
Yes? Okay. Then
But the sum of the potential energy and the kinetic energy is the same at all points. So potential energy plus kinetic energy is equal to constant. The sum of the potential energy and the kinetic energy is the total mechanical energy.
okay. Now when you say the sum of this potential energy and kinetic energy is mechanical energy. This you have to remember. It can come as MCQs also. So if I say what is the sum of potential energy, kinetic energy, what should we answer? It is a mechanical energy. What are they saying? They are saying that if this is the ball and is allowed to free fall, yes, so the potential energy is maximum. It is getting converted into kinetic energy. At the bottom, the kinetic energy is the maximum. You agree? Yes. Over here, the kinetic energy is zero and potential energy is mgh. What do you say?
Yes, ma'am.
Hello? Yes? You understood?
Yeah,
And
ma'am.
in this case, at the bottom here, kinetic energy is half mv square, remember? And the potential energy is zero. Agree? Agree or not?
Yes, ma'am.
That's it. You should understand. Somewhere up, the kinetic energy is zero. At the bottom, the potential energy is zero. That you have to understand. But when it is moving, anything which moves will have the maximum kinetic energy. Okay? When the ball is coming down, the potential energy is decreasing and kinetic energy is increasing. That you should understand. And when it hits the ground, the kinetic energy is the maximum. Understood? And at any point, whenever you say the sum of this potential and the kinetic energy remains constant, it will never change. But you can see that if the kinetic energy is more, the potential energy is less. But if you add them at any point, like from here to here, at any point, when you club it, when you sum it, when you add it up, it remains the same. Got it? For example, if potential energy is 10, the kinetic energy is 0. Now here it will be 9, 1, 8, 2. Are you understanding? And it will so happen that this will become 0 potential energy and this will become 10. Hope you understand.
Yes, ma'am.
Now we see transformation of energy, please. Yes.
Transformation of energy. The change of one form from energy into another form of energy is known as transformation of energy. Examples.
So we are going to see devices, energy in first form, second form, or third and fourth form. How it is being converted, that we are going to check. The first example that we are going to take is, please begin.
First, device. A body is thrown
Don't say
upward.
device. I've already said that. You have to start with the example.
Okay. A body is thrown upwards. Kinetic energy,
The
potential
first
energy,
form. The first form is kinetic energy.
kinetic
So it is
energy.
thrown upwards, right? What is
Okay.
the second form?
The
The
second
kinetic
form
energy is
is
getting converted
potential
into
energy.
potential energy. Are you understanding?
Yes, ma'am.
This is the first one. Whenever you throw a ball, for example, you're throwing a ball upwards. So it is moving. What is the energy? Kinetic energy. Yes? Then it goes up and then it starts coming down. So when it goes up, for some time it stops and then it comes down. You agree? You're a cricketer. When you hit a ball, for a fraction of a second it stops and then it comes down. Yes or no? That fraction of second will have the potential energy.
Yes, ma'am.
You hope, I think I'm making things very clear to you. What is happening? That fraction of second when this energy seems to have stopped and then start coming down, that time is having the potential energy. That ball is having the potential energy. It doesn't keep on moving up or on rise, but it stops and then it comes because that time the gravity is working on it. And then it starts coming down and then you get caught, whatever. You understand? Okay.
Yes, ma'am.
The second one.
A body is dropped from a height above the surface of the earth. Potential energy, kinetic energy, sound and light, heat, spark. If the body is stone or heavy metal falling on the
Falling.
hard surface, falling, sorry,
Okay.
falling on the hard surface.
Hard surface. Now, if I take a body, it is dropped from a height. Okay. Now, what is this body having? Which energy? Just now we did, I think so. Which energy it is having?
Potential energy.
Now it starts moving. Which energy it will get converted to? Hello? It's getting converted to which energy? Because it is moving. Boys, can you get me? Hello?
Ma'am.
Yes, ma'am.
Yes. So I'm holding the body over here. It is not moving. It's in my hand. The ball is in my hand. It has got potential energy. I let it fall. It comes down. It gets converted into kinetic energy because
Kinetic
it's
energy.
moving. It's moving. Yes. Now this body falls on the ground with a bang, with a sound. If it is a heavy object, if it's a metallic object, if it's a stone, it comes and drops with a bang, with a noise. So, which is that energy, the third degree? It could be sound, agree? If it is metallic, it can give out a spark. If it is light, you agree or not?
Yes, ma'am.
Hello? Yes? Because if it's a heavy metal which is falling from top, it can give a spark on the hard surface because there's a friction between the ground and the metal. It can give out spark. So light is also released. So that is a third form of degree. Third form of transformation. The first is potential energy when I'm holding it in my hand. When I allow it to fall, it falls down with a force. The potential energy is converted into kinetic energy. When it bangs onto the ground with a loud thud or sound, and maybe due to friction, the light is sparked. So this is the again transformation of energy from kinetic energy to sound or light energy. Hope you have understood.
Yes, ma'am.
Yes. Okay. Now we come to bulb. Start.
Filament bulb, electrical energy, heat and light energy.
That's it. Now you put on the electricity. There's a bulb glowing at your place, at your home. So when you switch on the light, so which energy started working? It was electrical energy. You agree? When you switch on the light, which energy you're making it move? It is electrical energy, the flow of electrons. Now that makes the heat and light energy of your bulb. You agree?
Yes, ma'am.
And all of you are understanding nicely?
Yes, ma'am.
So what are
Yes.
we seeing? We are seeing the transformation of energy. Got it? From one form to another form. Now we'll talk about the iron, that is electric iron. Yes, please begin. Hello. Please begin.
Yes, ma'am.
Yes, ma'am. electric ion, electric energy, heat energy,
Electrical
also light energy. If an indicator is
indicator. So let's take another example of electric iron. When you switch it on, which energy is working? Electrical energy. That makes the that gets converted to heat energy and we iron. If we don't get the heat energy, can we iron the clothes? No. So the electrical energy is getting converted to heat energy. And at times, you may be having those indicators on your iron. Yes, it shows that red light whether it is on or not, automatic. If you have the automatic iron, it shows whether the iron is on or not. And if it is more than what is required, automatically it becomes off.
Yes.
Have you seen that? So that shows if you have got the indicator, then the third transformation may take place that the heat energy is converted to light energy. Do you understand? Boys?
Yes, ma'am.
Okay.
Yes,
yes,
yes.
ma'am.
Some more devices. Start. Now we're going to work on thermoelectric power station. Should I take on or do you want to read better? Or should I straight away make you
As you
explain?
say, as you say, it will take
Which would
straight
be the
away
better?
then.
Yeah, I think I better take straight away. That will be better. The same thing I'm doing it again and again. Doesn't
I
work.
mean,
Okay, I will take it. I will
there
take
are
it.
only 8 minutes left.
Yeah, yeah. So thermoelectric power station. As the name suggests, thermoelectric power. So thermo is the heat. Now from where do you get the heat? You get the heat by burning coal. How do you get the heat better? By burning coal. Yes? So thermoelectric power station uses coal. So they burn the coal. Now what is inside the coal? Coal is chemical. Do you agree or not? Coal is chemical. Hello, it is organic.
Yes, ma'am.
It is a fossil fuel. I think you know all these things. So it is chemical. So chemical energy of coal is released, which gets converted to heat energy. And this heat energy is making the turbines move, the generator work. That is called as the movement is called as kinetic energy. And this movement of generator or turbine is converted to electrical energy. Have you understood?
Yes, ma'am.
Yes? How does it work? Hope you understand. The chemical energy of coal, because we know that it is a fossil fuel. So fossil, you should know that it is of chemical. That is plants, organic. Carbon, hydrogen, oxygen. You know that, CH2 group. Now this chemical energy, when you burn coal, so obviously what is happening? The chemical reactions. That is giving out heat energy. When you burn, it is giving out heat energy. We all know that. Now this heat energy is making the turbine move. That is kinetic energy because there's a movement involved. Now this movement of the turbine is generating the electrical energy with the help of a generator. Do you understand? Hello?
Yes,
Hello
ma'am.
boys. The same thing we can see in hydroelectric power station. Where do you get this hydroelectric power station? Near dams. You should know that near dams, we are having hydroelectric power station. What they do? The potential energy of water, which is stored in the high dam, very high dam, only there we can use this hydroelectric power station. So the potential energy is in the form of reservoir, where the water is not moving much on the other side of the dam. For example, this is the dam. This is the water flowing. And the water which is not flowing is called as reservoir. What it is called as? Reservoir, where you do fishing, yachting, boating, all these are reservoir. Now here the energy is potential energy. And when the water is flowing, that becomes kinetic energy. Do you agree?
Yes, ma'am.
Yes, so it
Yes,
is
ma'am.
falling from a very high, from a very high, what should I say, height. It is falling from a height, and that fall is having tremendous energy in the form of kinetic energy. So this potential energy gets converted into kinetic energy. So potential energy of water gets converted into kinetic energy, and that fall again makes the turbine move. It goes to the generator and gets converted into electrical energy. Have you understood? So with thermo power and with hydroelectric, we get electrical energy as a third grade. Understood, all of you?
Yes, ma'am.
Boys? Okay. Then we come to nuclear power station. Which energy are we using? The nucleus. That is the nuclear energy. What are we using? Nuclear energy. Like atom bomb, hydrogen bomb. When it explodes, it gives out heat energy. You should know that. Yes, when it blasts, what we get? The heat energy. So nuclear energy gets converted into heat energy. And this heat energy makes the kinetic energy. That is the movement. This heat energy creates the movement. That is the kinetic energy. And this kinetic energy gets changed into electrical energy. So thermo power, hydroelectric, nuclear power stations all give electrical energy. We can make use of these resources uh, as a means of generating electricity. Now we come to windmill. You know what is windmill? What we call as pavan chakki, uh, Suzlon, windmills you get in Malnad. You must have seen on the mountains.
Mhm.
On the mountains, generally you get the windmills. Yes, they also generate electricity. So, what is using? What this windmill is using? It is using the wind to move. So, when it starts moving, which energy is developed? Kinetic energy. When the wind is moving the windmill, so what is developed? Kinetic energy is developed. And this kinetic energy is converted into electrical energy. Next we have microphone. So the telephone, you have microphone in telephone. So what you are doing? Your sound energy gets converted into electrical energy. And that electrical energy will get converted into sound energy when it is by being received by another end. Got it? Vice versa. Microphone, sound energy gets converted into electrical energy. I'm speaking on the microphone. Do you get me, Vita? I'm speaking on the microphone. So what is which energy I'm giving? Sound energy. Now that is going through cable, that is electrical energy. Now on the other side, you are hearing me. So you got the loudspeaker. So this in the cable, which energy is going? Electrical energy. So electrical energy is converted to sound energy and you hear me. Do you get me?
Yes, ma'am. Yes.
I'm speaking on a
Yes,
microphone.
ma'am.
So what is my energy, Vita? Sound energy. Now it is going to the cable. So it got changed into electrical energy. Now you are at the receiver's end. You are the receiver. You pick up the phone. But through the cable, which energy is going? Electrical energy. So electrical energy gets converted to sound energy and you hear me. Do you get it?
Yes, ma'am.
The last one is gas stove. What are we using? LPG cylinder? Hello? We are using LPG,
Yes, ma'am.
isn't it?
Yes, ma'am.
Yes. So what is there inside LPG? Methane, that is chemical. Here is chemical energy. Agree?
Yes.
You have connected the LPG with your gas stove. When you put it on, when you start the gas, what do you get? You get heat and light. Agree?
Yes.
Yes.
In all ways, we have seen that energy is transferred or transformed from one form to another form. In how many ways? You saw that. I hope things are quite clear now.
Yes, ma'am.
Yes, boys? Okay, so I think we call it a day. I hope you have understood nicely. This is totally different topic altogether. So we'll do the law of conservation of energy again tomorrow, a means of revision. That's the purpose that I have been taking so many odd slides again and again on the same topic, so that things are quite clear
Yes.
to you and you understand it well. Fine. So and I pray that please write down your in-text questions and please show it to your follow-up teacher without fail. Okay, boys.
Okay, ma'am.
Hello. Oh, thank you, thank you. Okay, then enjoy and have a good day, beta. It's already time up.
Thank you, ma'am.
Bye, beta.
Bye, ma'am.